Hi everyone. If you watched part one of my video on graphing quadratic functions, you'll see that I used this technology called graph-free, but then I also mentioned that in part two, I was going to show how I was going to do this on the board in case you want to see a live person doing this sort of thing on the board. So what I've got here, I've got three functions. In blue, I'm going to have f of x equaling x squared. In green, g of x equals x minus 1 in parentheses quantity squared. And then in orange, h of x equals x plus 1 quantity squared. So let's take a look as to why horizontal transformations work the way they do, okay? So what I did was I picked some x values. I like to always work with -3, -2, -1, 0, 1, 2, and 3 as my x values. Now let's see what's going to happen for the corresponding y values here. If you make a little chart here, for f of x, if you take a -3, plug it in here for x, square it, so that's -3 times a -3, you get a +9. And then -2, -2 squared, -2 times -2 is a +4. -1 times a -1 is 1, 0 times 0 is 0, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. Okay, so let me just do the blue for now. Okay, this is what I call the base graph when it comes to parabolas, is when it's like y equals x squared or f of x equals x squared, okay? So if x is -3, y is way up here at 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to be way up here somewhere. When x is -2, y is 4. 1, 2, 3, 4. So I'm right here. When x is -1, y is 1. When x is 0, y is 0. When x is 1, y is 1. Now, as what we're going to see now is we're going to see this thing called an axis of symmetry. Okay, what that means is half of our graph is going to be on one side of this axis of symmetry, and the other half of the graph is going to be on the other side of the axis of symmetry. Now, this axis of symmetry is an equation, okay? If you're talking about a parabola that's opening up or opening down, then this axis of symmetry, it's going to be the equation x equals some number. If you take college algebra, and maybe some intermediate algebra classes, if you're taking mine, probably not, but if you're taking intermediate algebra elsewhere, you may see sideways parabolas, and that would mean you're going to have an axis of symmetry that would be y equals some number. Okay, but for now, if it's opening up and down, our axis of symmetry is going to be x equals 0 in this case, okay? So it's a vertical line going right through the x-axis, if you will. Or going right through the y-axis, excuse me. All right, keeping on going. When x is 2, y is 4. And when x is 3, y is 9. So I've got this graph going. All right, so that's going to be the base graph of this parabola. Now in green here, what I've done was I said, okay, let's take a -3 and plug it in here for this x. -3 minus 1 is a -4. -4 times -4 is this +16 that you see here. And let's keep on going. -2 minus 1, it's a -3, right? -3 times a -3 is this +9 you see here. -1 minus 1 is a -2. -2 squared is 4. Notice my values have not started to repeat yet. When it comes to parabolas, you want to start seeing repeating y values or repeating g of x values in this case. 0. 0 minus 1 is 1, -1. -1 squared is a +1. Still not repeating anything yet. If you plug in as 1 for x, 1 minus 1 is 0. 0 squared, still 0. Still nothing repeating. But now we're going to see a repeat. 2 minus 1 is 1. 1 times 1 is 1. So see how I picked up another y value here? Now 3. 3 minus 1 is 2. 2 squared is 4. And I picked up another 4 here. Let me graph these guys. This 16 is off the chart, so I'm not going to mess with that. So let me do -2 and 9. -2 and 9 is going to be this guy right here. -1 and 4 is going to be this guy here. 0, 0, excuse me, 0, 1 is going to be this guy here. 1, 0 is this point here. 2, 1 is this point. And 3, 4 is going to be this point. And then when you graph this thing, look what's happening. My graph has shifted to the right one place. Okay. Now let's examine this a little further based on what we're seeing in our charts here for f of x and g of x in particular. See how as my x values increase, my 9 here is actually shifted down 1 unit, down here to when x was -2, right? It's just like my 4, it moved down 1 here. 1 is moved down. So what's happening is your y values, such as they are going to shift down 1 unit. They're going to increase 1 unit for your x kind of thing. I mean, as x increases 1 unit, it's going to pick up that previous x value. And that's why we're seeing this shift to the right when x minus 1 is existing there. Now, that might be kind of a lot to take in. Sometimes people just say, okay, you know what? Whatever that number is, it's the opposite of what you might think. So if you see a -1, then say, okay, it's shifting to the right 1 place, positive 1 unit to the right. Sometimes people like to just say x minus 1, set that equal to 0, and say, okay, x equals 1. So that means my vertex is going to move to the 1, or the whole graph is going to shift 1 unit to the right. All right, that's another way of thinking of it. All right, let's beat this thing to like a dead horse here. Let's look at this g of x now. If you plug in a -3, -3 plus 1 is a -2, -2 squared is this 4. -2 plus 1 is a -1, square that, you get 1. -1 plus 1 is 0, square that, still 0. 0 plus 1 is 1, square it, you get 1. 1 plus 1 is 2, square it, you get this 4. 2 plus 1 is 3, 3 squared is 9. And then this 3 plus 1 is 4, square it, you get this 16. So that's where those numbers are coming from. Graphing them, if x is -3, y is a 4. So I'm over here at -3 and 4. And if you guess that your graph's going to, this blue graph is going to shift to the left 1 unit, that's a pretty good guess, because that's what's going to happen. -2, 1 is going to be this point here. -1, 0 is this point. 0, 1 is this point. 1, 4, 4, and 2, 9 is way up here. So as you can see, my graph is now shifted 1 unit to the left from the base graph. And that makes sense, right? If you look at our base graph, the y values, like for example, I've got a 4 here. Where's that 4 located on this orange graph? It's actually where my x was a -3. So it's actually 1 unit less for the y here than what you see here. So again, you can use the thought of, okay, whatever that number is, take the opposite of that, so -1, which means shift the whole graph to the left 1 place. All right, I hope that helps you figure out how to work horizontal transformations. This video is getting pretty long. Oh yeah, it's way long. Let me erase all this and I'll do a part 3, which is going to deal with vertical transformations.